All right, the second part of this lesson is about the segments in circles. There are several different types of segments. Chord segments are the two segments of each chord that are formed when two chords intersect in the interior. So I have these two chords that intersect. AE is a chord segment of that first chord right here. EB is a chord segment of this chord AB. The other two chord segments would be EC and ED. Would be chord segments of this segment CD. When you have two chord segments that intersect in the interior of a circle, the product, that means multiply, of their segment lengths is equal to the product of the segment lengths of the other chord. What that basically means is if I take these two segment lengths, AE and EB, and multiply them together, AE times EB is going to equal the other two segments products, CE and ED, times ED. So AE times EB, this segment times this segment is going to equal CE times ED. The second type of segment that we're going to look at is if you have a secant or what the secant and the external secant segments are. So the secant segment is going to be just exactly that, a secant that is a segment. We know a secant intersects a circle and 2 points. The external part is the part that sticks outside the circle. And then there's a couple of properties that happen with secant segments and the external properties. This picture shows two secants that both have this point E in common. And if two secants share the same endpoint outside the circle, then the product of the lengths of the secant segment, the whole thing, is equal to, times the external part is equal to the other product of the whole thing times the external part. So what that means is EA, that is the part sticking out of the circle, times the whole thing, EB, is going to equal the same thing with the other secant. EC, that's the part sticking out of the circle, times the whole thing ED. This is the external part times the whole segment. Those two things are equal. The last thing that we'll talk about is if you have a secant and a tangent. And what happens here is if they share the same endpoint, you can take the tangent segment, which is this one, the tangent segment, touches it in 1 point, and square it. EA squared is going to equal the product of the external part and the whole part of the secant. So EC times ED. And this will make a lot more sense when we actually look at problems. Again, this is the tangent squared equal to the external part of the secant times the whole secant segment. All right, looking at these examples, I can see that this one fits this first picture that we looked at with the two chords and the products of those segments are going to be equal. So when you're doing your assignment, match it to the picture that it looks like, and that will help you figure out what rule to actually use. When I look at this, I have a 3 and an 8 as the two pieces of this segment BD. 8 and 4 X and 4, are the two pieces of segment AC. So when I do their product, 3 times 8 is going to equal X times 4. Those are the products of the two segments of each of those chords. And then I multiply these together. 3 times 8 is 24. 4 times X is 4X. And then divide to solve for X. You divide by 4. You get X equals 6. Okay. I want you to try part B. Just pause this and try to finish that piece or that problem the same way we did part A. And what you should have ended up is with this 3.2. It's okay to have a decimal. You would have X times 5 equal to 4 times 4. This is 5X equals 16. Divide by 5. You get X equals 3.2. All right, the problem on this back page is another one of those chord problems where I have two chords that intersect. I'm going to do the product of their segments. So 3 times 8 is going to equal 3x times 2. 3 times 8 is 24. 3x times 2 is 6x. Remember, you can multiply the coefficients. Divide by 6. You get x equals 4. All right, and then the last problem we have like this is the next one, part D, where again it's the two chords that intersect inside the circle. So the product is equal. So x times x, both of those are x's, and 4 times 9. Remember that when you have x times x, that's going to give you x squared, not 2x, x squared, and then 4 times 9 is 36. And then to solve an equation with a squared term, you take the square root. So your x would equal 6. Again, any problem that you have that has the chords that intersect inside the circle, you're going to solve like this, where the two pieces multiplied, the product of those two segments, are equal. The part E on this is one of those that has two secants. If I can see, this is a secant because it touches the circle in two places. The other segment is a secant because it touches the circle in two places. And what it told us is that the external segment times the whole segment, which would be 10 when I add them together, is equal to the external segment, this 5, times the whole segment. Well, if I have x plus 5, it is just x plus 5. It is not 5x. You cannot combine things that are not like terms. So the external part here is 4 times the whole segment is 10. The external part here is 5 times the whole segment is x plus 5. And I'm just going to solve this equation. You end up with 40 equals, distribute your 5, 5x plus 25. Subtract 25 from both sides. You get 5x equals 15. Divide by 5. And x equals 3. Again, if you need to pause that, I'm going to skip part F for right now. We're going to go back and do that one in just a minute. Part G, I have, again, two secants. That means that the external part times the whole thing is going to equal the external part times the whole thing. So here my whole segment is 3 plus 6, which is 9. Here the whole segment is x plus x, which is 2x. If I have one x and I add another x to it, how many x's do you have? Well, you now have 2 x's. And then I'm going to do the rule that says 3 times 9, that's the external part times the whole piece, is x, that's the external part, times 2x. 3 times 9 is 27. X times 2x is 2x squared. You multiply the coefficients, multiply the variables, and then I still have to get x by itself, so we're going to divide both sides by 2. You get x squared equals 13.5. And then when you have that squared, you're going to take the square root. You get x equals about 3.7. You can do that in your calculator. Okay? And then I'm going to skip part I on this one. So I'm going down to skip part H. I'm going to part I. Notice that this picture is a little bit different. This is a tangent and a secant. That's the third rule that says the tangent squared is equal to the external part times the whole thing of the secant. So the external part is 9. The whole thing is 9 plus 4, which is 13. Again, the tangent squared, that's 2x, and then I'm going to square that, equals 9 times 13. The external part times the whole secant segment. With a squared on the outside of parentheses, you do have to square everything inside. 2 to the second power is 4. X to the second power is x squared. 9 times 13 is 117. I'm still going to get x by itself completely, so I divide by 4, and you get x squared equals 29.25. Then I take the square root of both sides, and you get x equals about 5.4. Again, this is a tangent and a secant, so we're using that second rule. The last one that I'm going to look at, and then I'm going to let you try some, is this part J. Again, when I'm looking at this, I have a tangent and a secant. That is that last rule where the tangent squared is the external times the whole secant segment. So the whole secant segment is 9. 5 plus 4 is 9. The tangent squared, x squared, equals 4 times 9. External times the whole secant segment. 4 times 9 is 36. Then we take the square root of that. You get x equals 6. So 3 different rules with 3 different types of problems. We have the first rule where the two chords intersect and you multiply the two pieces of the segments and they're equal. The second rule where you have two secants and you would multiply the external times the whole thing. And then the third rule where you have a tangent and a secant where you multiply the tangent squared is the external times the whole segment. What I want you to do is go back to H and work this problem. Pause the video and see if you can get that problem. It will be very similar to part G right beside it. Alright, with this one, you should have gotten that the answer was 2. The whole segment here, these are two secants, so it's the external times the whole thing. The whole thing is 1 plus 2x. That is not 3x. It is 1 plus 2x. The whole thing here is 5. So when I do the external, 1 times 1 plus 2x equals external times the whole thing, 1 times 5. Distribute that 1, it does nothing. 1 times 5 is 5. You subtract 1 from both sides, you get 2x equals 4. Divide by 2, you get x equals 2. Now turn over to the last page and I want you to try these two problems, K and L. These are the tangent and secant problems, which are the last rule that we went over. Alright, with K, again, you were supposed to pause the video and do that one. You should have gotten about 7.4. That is your answer. This is the one where you square x squared, equals 5 times the whole segment, which is 11. So it'll be x squared equals 55. Take the square root with your calculator. That gives you 7.4. And then L, you should have gotten about 13.9. Same type of problem. X squared, that's the tangent segment, is 12 times 16. When you do that, multiply those two, take the square root, you get about 13.9. So we've had several different types of problems with this section. The first thing that we did was we looked at the different angle relationships. So you have an angle relationship that happens when you have a chord and a tangent that intersect. Remember that the angle is half of its intercepted arc. We have another angle relationship that happens when you have two chords that intersect, which means that like this angle is the half of the sum of its intercepted arc and the vertical angle's intercepted arc. So you add the two arcs together and divide it by 2. The third angle relationship that we had was what happens if you have two secants, a secant and a tangent, or two tangents, and that is this external angle is the half the difference of the arc and its the two intercepted arcs. Because it's an external angle, there will be two arcs that are intercepted. So you subtract them and divide them by 2. So the first one is half that arc. This one you add them and divide by 2. This one you subtract them and divide by 2. And then we had our different types of segments. With the first segment, we have two chords that intersect. And the product of the two pieces are equal. So the product of those two segments is equal to the product of these two segments. We have our two secants, like this, where we have this piece times the whole segment is going to be equal to this piece times the whole segment. And then the last one, we have our tangent and secant. So if I have a tangent and a secant, this is squared and is equal to this piece times the whole thing. Now you do have a homework assignment, so get busy on that and I will check it next class.